Well, good evening, everyone, from cyberspace. This is Tom Jackson at Jackson Systems. Thank you so much for joining us tonight to learn a little bit more about Belimo actuators and valves. We have a few housekeeping things. First off, I want to say this is a virtual training, so I'm here in Indianapolis, but our presenter is in his home. So bear with us if we have a little glitch there, because we've got a lot of different things spinning around. So hopefully we'll proceed without a glitch. But anyway, a couple of housekeeping things. First off, as you navigate through the evening, you'll notice on your screen there's several different boxes that we want to just make sure that you're familiar with. In the upper left-hand corner, you'll notice that's where you submit questions, and throughout the night, I'll be reading those and submitting those to Ken so he can answer your questions. So feel free to submit those as we go through the night. The bottom left-hand corner is a short survey at the end of the presentation tonight. We'd love it if you'd fill out some information there. It helps us improve our trainings and give us ideas for new topics or new technology. We would love to get your feedback. In the bottom two squares there, you notice on the left-hand side, it talks about there's some PDFs with different information from Jackson Systems. So if you want to learn a little bit more about Jackson Systems, you can find that information there. On the bottom right-hand side there in the middle is the information from Belimo. So all the things that Ken's going to be talking to us tonight is there for you. So if you want to download those PDFs, feel free to do that and share those with other team members. In the upper right-hand corner is the actual presentation that Ken will be walking us through. And then finally in the bottom right-hand corner, lots of squares. So lots of things going on there. But in the bottom right-hand corner, tonight's class is not NATE certified. But if you do watch the class, we'll keep track of that, and we'll actually send you a certificate so that you could show that to your employer or share it with someone else in your organization, or however you want to use that. Just keep track of what classes you've taken. So that's kind of the overview. A few more things from the technology side is, if I advance the slide here, down at the bottom there is the dock. Those are kind of the shortcuts to all the different portions of the screen that you're viewing tonight. So you can click on those to bring different squares up or minimize them. And then finally, here are some housekeeping things as it relates to best viewing tips. First off, if you're at home and you've got family members, if you could ask them to stop streaming Hulu or Netflix or Disney Plus during this, that sure helps. And sure, as you know, the entire world is trying to do everything virtually now. So if we can conserve some bandwidth, that would be great. If you watch this on an actual laptop or PC, that's the best. Cell phones and tablets and so forth, they just don't do a good job with receiving all the information. So if you can do it from an actual PC or laptop, that's always appreciated. Don't use Firefox, Netscape, or Internet Explorer. They just do not do a good job of rendering all the content, so we'll put a big X through those. Use something like Chrome or whatever the... Safari. Yes, they're yelling at me in the background, Safari. So anyway, and then the number one question we always get at all of our trainings, are you going to be recording this and can we watch it later? And the answer to that is, as always, absolutely yes. You should have received a link to join us tonight. You can actually use that exact same link to get to the recorded content. So if you want to watch it again, or if there's a little nugget out of there you want to capture, you can definitely do that, or share it with your other team members. That would be outstanding. Usually takes us just about 2 days to do all the post-production to make it look really pretty and presentable. So you got that. And tonight we're going to be, again, talking with Belimo, with Ken Dorn from Belimo. He's going to be talking about actuators and valves, and I think everybody is probably run across a Belimo valve or actuator in their time in the field. They really are the premier manufacturer when it comes to Belimo actuator. Well, of course, they're the best at making Belimo valves, but they're the best in the industry when it comes to making valves and actuators. We use a ton of them here at Jackson Systems, both for residential applications and commercial applications, and I know Ken's going to be covering a lot of that. So Without any further ado, I think you should have had Ken join me live there on the screen. How's it going, Ken?
Hey, Tom. I'm good. How you doing?
And where are you coming from this evening?
So I am in beautiful Chicago, Illinois.
Beautiful Chicago, Illinois. Are you still in lockdown in Chicago?
We are on lockdown through the end of the month, and we'll see what happens. We're kind of we're on pace to move to the next step so far at the end of May, beginning of June. But again, who knows?
Who knows? All right.
Yeah.
Well, we really, really appreciate you spending some time with us this evening and educating us on some Belimo product. And without any further ado, I'll turn it over to you, Ken. Again, thank you very, very much. And don't forget to submit those questions there in the Q&A. And as time permits, I'll shoot those over to Ken and we can answer your questions.
Okay. Thanks a lot, Tom. And thank you to everybody for joining us for this webinar this evening. We're going to cover a few different topics here. On the air side, which we call it, so damper actuators, we're going to cover nomenclature, the different actuator types and applications for them. And then the last thing on damper actuators is going to be normal versus failed position. It's going to be an explanation and exercise in that. Then we're going to talk valves, and with the valves, we're going to talk valve sizing. We get a lot of questions on that, how to properly size a pressure-dependent valve, what is CV, and things like that. We're going to cover that. And then the last portion, we're going to do a quick sort of overview of our retrofit applications and our retrofit options. That's something that we'll cover kind of the basics. We could go something more in depth on that topic if you guys feel the need, and that's something you can pass along in the notes to Tom and the crew if that's something you'd be interested in. We're going to start out quickly with an introduction to Belimo. You've probably heard the name, our products, but giving you a quick background on what Belimo is all about. So the company was founded in 1975. The world headquarters is located in Hinwil, Switzerland, which is just outside of Zurich. We entered the U.S. market in 1988. There's approximately 1,900 employees for Belimo worldwide, over 80 countries. The headquarters for the Americas, which include North and South America, is in Danbury, Connecticut. They're right outside of New York City, about an hour and a half or so outside of New York. We also have a facility in Sparks, Nevada. In Danbury and Sparks, we have customer service, tech support. We have manufacturing and assembly at both of those facilities as well. And one kind of interesting or fun fact, if you want to call it, about Belimo is in January of 2020, we sold our 100 millionth actuator. So 100 million actuators have been sold by Belimo since 1975. That's kind of a crazy number. I had to do a double take when I first saw that. So Belimo, I'm going to kind of go through the name. People often think it's Italian or, what is it about somebody's last name. It's actually an acronym for three words that are in Swiss German. So in Zurich, Switzerland, they speak their version of German. So the BE, the first two letters in Belimo, is beraten, which means to consult. The next two letters is LI, and that's for Lieferin, which means to deliver. And the final two letters, making it the MO, is montieren, which means to mount. So that's kind of an interesting explanation on what the Belimo name means. So this right here is the first spring return actuator, direct coupled spring return actuator that Belimo assembled and sold. It looks quite a bit different than what you're used to seeing now. You can see there's no orange, there's no logoing or anything like that, but that was the first Belimo actuator on the market. So we're going to start out by talking about actuator nomenclature. And we're going to start out with a little quiz question here. So which of these two actuators is the spring return model? First one is AFB 24-S N4, or is it AMB 24-SR? Give you a second or two here to think about it. Well, the answer is it's the AFB 24-SR. Now we run into a lot of cases where people think the AFB 24-S N4 is the spring return model. So SR does not stand for spring return in Belimo nomenclature. We are a Swiss German company by heritage, so some of our nomenclature, especially on the damper actuator side, has some translations that are needed. So first off, we're going to explain each position within our Belimo nomenclature. It's going to go a step-by-step process here and what each one means in a breakdown. So first position is torque. And in our particular example that I gave you before, the AFB 24, that means it's an AF actuator, which means it's 180 inch-pounds of torque is required. It's how much the maximum that this actuator can do. So what is torque? It's a turning or rotational force. It's pretty much like what the pressure of what it takes to turn a screw or to turn a nut. And it's also the same thing you need when you're turning the wheel of your car. So a 1 inch-pound actuator, as you can see in the diagram, could lift 1 pound if it were 1 inch from the center of the damper shaft. So we're talking leverage is involved with this as well. So a 1 inch-pound actuator could actually lift 2 pounds if it were a 1/2 inch from the center of the damper shaft. So that's kind of a quick explanation of torque. So how do we find out what our torque is in inch pounds? It's a pretty simple equation. It's the damper area in square feet times the rated torque loading of the damper in inch pounds per foot squared. And that's going to equal the torque in inch pounds required to operate a damper. In this example we're showing here, we have 12 square feet times 5 inch pounds per square foot equals 60. So our torque for this actuator that I can do is 60 inch pounds. So position 2 in our nomenclature is what kind of actuator model it is. And this is where we get into the Swiss German words versus what our particular words in English mean. So in this example that we had, it was an AF, F meaning fader in German, which translates to spring. So any actuator you see from Belimo, whether it's a damper actuator or on a control valve, the F is going to mean a spring return. The M means motor, which translates to motor, easy translation from German to English, but that's going to be our non-fail-safe actuators. The K stands for condensator, which translates to capacitor in English. Those are going to be our electronic fail-safe actuators. And we also have a couple of different versions here. We have H for hub, which is a linear stroke actuator, and U for Umdrehung, which is a rotational actuator that's going to spin 360 degrees. We'll get some pictures to look at some pictures of these as well as we move through the slides. So why choose fail-safe? What does the application demand? As we're looking at this slide here, it illustrates air handling unit in a school on a cold day. The outside air passes through the heating coil. It's mixed with return air and is supplied to the classrooms and the rest of the building. If there was a power failure, usually engineers are going to specify that the damper should fail closed to protect the coil. If water in the coil freezes, it can burst the coil tubes. That can be a very expensive repair. And even nowadays with glycol in our systems, which can help to prevent freezing, much like it does on the radiator of your car, engineers are still specifying spring return actuation in those situations. So why would you choose an electronic fail-safe versus a spring return as fail-safe? So when the application demands any of the following situations. We have a high torque situation where you need more than 540 inch-pounds. You need a quick actuation and fail-safe. If you need a linear stroke actuator with fail-safe mode, if you'd like adjustable fail-safe options with electronic fail-safe, you can choose what percentage of open or close you'd like it to go to. This allows for some brownout protection, and it also offers you the ability to do some diagnostics. So here's just a look at our linear stroke actuator and the rotational actuator that we talked about earlier in our nomenclature. And now we're moving on to position number 3, which is the speed of the actuator. So in the example that we gave, it was just blank, and that means it's going to run at normal speed, which is 150 seconds. There are also some options, and these aren't available on all actuators, but they are available on select models. But you see the C, which is for fast running, which means that the actuator can open or close in 35 seconds. You have the Q for quick running, which means you can have it set to open or close in 2.5 or 7 seconds. And then we have L, which is the slow running actuator, which is 75 seconds. Position number 4 is set for options, and there are basically 2. We have 3. We have the basic and the blank, which are the same, which means it's a stock product. It means it has a standard 150-second runtime. You have a standard, it's 1/2 inch to 1.05 inches clamp, and it's a 3-foot appliance cable that comes with a conduit to connector. So any of these that are in the basic or the blank style means they're in stock on our shelves and can be shipped out within 1 day. So if you place an order in the morning, first thing in the morning, odds are it might go out that same day. If you place it anywhere from mid-morning to later in the afternoon, it's going to ship out the next day. And we're talking about the X, which means it's customizable. It means you have a choice of a 10-foot or 16-foot cable with the conduit connector. And then the other options are factory programming. Runtime can be programmed. You can program the control signal, and you can control the feedback as well. Position number 5 is our power supply. And in the actuator in our example, we're using the 24 volts or VAC. We also have a 120 volt option, a VAC option, and a 230, and then UP in our nomenclature stands for universal power. Position 6 is going to be talking about the control options. So we have blank is for on and off. A -3 is floating point. A -SR is modulating. And again, that's a Swiss German word. That means modulating, steady, regular. PC is phase cut. It's not something we see in the market all that often. The same with the Econ-R03 and the MFT95 and the MFT-20. Those are all for specialty applications or for a direct replacement to old products that are out in the market. So with the next slide, we're going to look at the control signal overview. So we can have a little description of what the on-off or open or close means. Basically, that means the actuator is either going to fully close or fully open. Those are the only options. We have the 3-point tri-state or floating point. They're all kind of called the same thing. That means the actuator has both clockwise and counterclockwise inputs. And if at some point you do lose a signal to either one of those, the actuator is going to stay in whatever place that signal happened. The next one is proportional control or modulating. Basically what that means is the actuator is going to drive based on the voltage output that's given. So in this 0 to 10 VDC example, if you give it 5 volts of power, that means the actuator is going to power to 50% open or 50% close. So the other option here is the 2 most common, 0 to 10 and 2 to 10 VDC. We also run in from time to time to a 0 to 20 and a 4 to 20 milliamp output, and that can be achieved from the 0 to 10 or 2 to 10 VDC setup actuators by installing a 500 ohm resistor. So as I mentioned before, pulse width modulation, phase cut, they are not used very often in today's marketplace, but they're the ones you may run across from time to time. And then the next one is multifunction technology, which we'll talk a little bit more about on the next slide, and that's something that's proprietary to Belimo. So this was developed by Belimo for incorporation into our air damper and control valve actuators. So the MFT provides the ability to program specific characteristics of the actuator, and those include these ones listed below. So you can control the input. You can program it to be an on-off actuator, a modulating or volts DC actuator. You can program it to be a pulse width modulation, or it can be set up for a floating point as well. Feedback is programmable, so you can program signal feedback values, motion values as well as programmable runtime. It can program the torque and the rotation adjustments as well. And you can do that all in the field with this little tool here called ZTH. This is something that's available from Jackson Systems or any of your Belimo partners out there. That's something you can use. You plug into an MFT actuator and you can make all those changes to it. The last point below, the PC tool allows you to run diagnostics. You can look at runtime ratios and logging capabilities. And what that is you would connect the ZTH to a port, and then plug into your PC, and you'll be able to do all those additional analytics. So position number 7 are the other options. That basically means you can have a dash S, means it's a built-in auxiliary switch, which you see in that actuator there. T is for terminal block, which you see there, and blank is just our standard cable version. And if you want one of the other options here, like the built-in auxiliary switch, that's maybe going to add a little bit more to the price of the actuator. And actually, if you went to dash T and terminal block, it's going to reduce the cost of the actuator slightly. And the last position in our nomenclature are the NEMA options. So if it's in this particular instance, in the one that we were specifying it, so it was an N4, which means it's a NEMA 4 enclosure. There's also a NEMA 4H with a heater built into it, and we're going to cover the NEMA options here in this next slide. So Belimo actuators as a whole are going to be either NEMA 2, which is most of the actuators on our CCVs, our glow valves, our energy valves, and most of our regular damper actuators. And then NEMA 4 enclosure and NEMA 4X are mainly are best for situations where there's going to be water or particulates as dirt, rain, snow, and water that could be get onto the actuator surface itself. So as you can see here, the difference between 2 and 4 is that the NEMA 4 enclosure is going to provide protection against hose-directed water. I just always love that term. I wonder who came up with that particular thing. Like somebody's testing it, holding a hose over the actuator and seeing if it's keeping the water out. And then the NEMA 4X, the only difference between that and the NEMA 4 is that the X provides you with some sort of corrosion resistance. So if you're in a manufacturing facility or anywhere where there might be corrosive elements in the air, that's going to protect the inner workings against that. Important thing to note too on the 4 and 4X is will be on the interior workings, will not be damaged or affected at all if there's formation of ice on the exterior of the enclosure. So we're going to just do an overview of the actuator types themselves, starting with our non-spring return line. So as you can see on the left-hand screen, we have various torque ratings from 18 inch-pounds all the way up to 1,400 inch-pounds. So the one thing about our actuator series between non-spring return, spring return, and electronic failsafe is that maximum torque ratings are going to vary. And as you see here, we have a lot of the same nomenclature points we talked about before. So we have the quick running for Q, C for fast running, a basic for customizable version. Power requirements are all very similar, and then the control points as well. So here's a look at our non-spring return actuator products. We have the CM, which is a tiny little guy at 1,800 inch-pounds, all the way up to a PM, which is 1,400 inch-pounds. If you're familiar with our butterfly valve offerings, that actuator may look familiar. It was a replacement for our SY actuators on our 6-inch to 12-inch valves, and it's actually sitting right up back there behind me on the shelf. You can kind of see it in the background there. So spring return actuators, we kind of had a preview of this when we were walking through the nomenclature steps. Maximum torque load for the spring return is 270 inch-pounds. You can go as low as 22. Here's a look at what all the actuators in that series look like. If you haven't seen an EF in person, it is a big piece of machinery. It's about this wide, about this tall, and it weighs a lot. It's a heavy-duty actuator and can take care of cover a lot of applications for us. And then finally, we were talking about electronic failsafe damper actuators, a smaller offering here. So we have the NK, which is 54 inch-pounds, the GK, which will do is 360 inch-pounds, and then we have the big boy PK, which is a electronic failsafe actuator that can do up to 1,400 inch-pounds of torque. Here's a look at the electronic failsafe versus a product offering. The one thing you'll notice if you've seen like our EF actuator that does 270 inch-pounds, if you compare the size of that to the GK, it's a crazy amount of difference. You could probably fit at least 2 GKs, possibly 3 in the same space as what the EF takes up. And that's just because the spring mechanism is so big that it requires the actuator to be that big in size. One thing I also want to touch on is our fire and smoke offerings. We have a full offering of fire and smoke and fire safety actuators covering 18-inch pounds all the way up to 180. Here's a look at what they look like. They pretty much look very similar to our standard actuators, just a little bit more robust coverings. It's something I wanted to point out about these as well is in the past, when you were replacing a fire safety or fire and smoke damper actuator, you had to replace like for like, which meant that if you had a CB, which you can see in this picture here, a CB actuator, it needed to be replaced with the same brand. But that has recently changed within the last few years. And now, as long as specifications match up, you don't have to do like for like. You can use a different manufacturer when replacing a fire and smoke actuator. And just a couple other things I want to touch on as far as applications and accessories for our actuators. As opposed to our valve actuators, where we recommend they be installed above the horizon or 90-degree point, our damper actuators can be installed in a 360-degree pattern, and it's not going to have any effect on this former function. We have a jack shaft adapter kit, so if you run into a damper that has a jack shaft, we have an adapter kit that would allow you to connect to the jack shaft and use a Belimo actuator on it. We also have this great accessory called a crank arm adapter kit. So this is going to include everything you might need when you're going to mount an actuator or do a retrofit on an actuator on a damper. So you don't need to get lost in ordering specific ball joints or crank arms. It's going to include everything you need. Especially, you guys probably know it's not always known if the actuator is going to be direct coupled or not. If you have a crank arm kit in your truck, you'll be good to go. Do you have a question, Tom?
I did actually have two quick questions.
Yeah.
First, why is everything that Belimo makes orange? And then the second question is, does Belimo manufacture a lot of valves and actuators for other manufacturers?
Okay, so the orange, I have not gotten a definitive answer on why Belimo had gone with the orange color. And that's something I might have been told in the past, but I can't seem to remember it off the top of my head. But I can find out and let you guys know.
That's all right.
I would like to say because it stands out, and it really does stand out amongst the competition. And if you're trying to locate an actuator or a valve in any kind of application, you'll be able to see the orange a lot easier. And for the second question, yes, Belimo does have partnerships with OEM contracts with other companies out there. So you may see Belimo actuators on various products throughout there. They may not be orange in color.
We don't know 100% why they're orange. Belimo makes a lot of products for a lot of different other HVAC manufacturers. And then Jess asked a question, which actuator would you use for a pool air handler?
So that's a good question. I would probably use something with a NEMA 4 enclosure on it, just because of the moisture and everything you're going to find in humidity that's going to be in a building, in a pool area. That's what I would suggest, something with the NEMA 4 enclosure to be on the safe side.
Yep. And then one more question I can get here. Does Belimo make valves that respond to both analog and digital inputs?
Yes, we do. We do have valves that will do that.
All right. Well, I think we're caught up then.
Okay. We'll move on to the next slide. And yes, of course, with any technology, when we've done this before, we did a test about a week ago. We had absolutely no issues. Everything was smooth sailing. But now we get to the actual event, and stuff happens. So the next thing, or the final thing we're going to cover here on the damper actuator side of things is normal versus fail. So we run into this quite a bit, where the designation between the two can sometimes be murky and hard to understand. So we're just going to do the kind of definitions of both, and then we're going to just do it through a quick exercise, which will kind of hopefully make it a little bit easier in your head as to which is which. So normal, or like normally closed, normally open. What that means is that under normal operating conditions, removing the control signal will drive the actuator to its closed or open position. And that's going to be on all non-fail-safe actuators. So the fail close and fail open, that's when power fails. The spring return actuator will drive the actuator to its fail position, either whether it's closed or open. So we're going to do, like I said, a quick exercise here to go through to kind of get yourself a little bit more familiar with what we're talking about. We're talking about open and closed, or normal and fail. So we have a spring return, we have a spring return modulating actuator with 2 volts being fully closed, 10 volts being fully open, and we have the fail position as open. What happens if the control signal is lost when this actuator is in 50% open mode? What position does it go to? Does it go to fully open, fully closed, remain in current position? We're not sure. It is going to go to the fully closed position. So signal loss means it's going to go to its closed position or 2 volts position. Okay, exercise 2. We have the same actuator, and we're talking about power loss. What happens if we lose power on this actuator when it's at 50% open? It is going to go to the fully open position. So as you can see on the setup, we have it set to fail open. So when we lose power, it's going to go to that fail position. We're looking at the next step in LMB 24-SR. So it's a non-spring return modulating actuator. We have 2 volts being open and 10 volts, 2 volts being closed, 10 volts being open. So what happens in this particular instance when we lose control signal and the actuator is 50% open? It's going to go to that fully closed position. Same actuator, we're looking at this, so we're looking at a non-spring return, non-fail-safe actuator, 2 volts closed, 10 volts open. What happens if we lose power? It's going to remain in its current position. Sorry, I was a little quick on the slides there. Okay, we've got 2 more of these. The next one is going to be our electronic fail-safe actuator. In this instance, it's modulating, and fail position is 40%. So what happens if the control signal is lost when the actuator is 50% open? It's going to go fully closed. The same actuator, what's going to happen in this situation? So we have the actuator is at 50% open when we lose power. What position is the actuator going to go to? It is going to go to 40%. Fail position is 40% open. So that's the difference between the electronic fail-safe and all the other ones out there. And the spring return is that you can set the fail position. And Tom, I see you have a question.
Yep, we actually have 2 questions.
Okay.
First one is, are there multi-turn actuators in the Belimo line?
Multi-turn by meaning that that's a good question.
Yeah, I don't honestly know. He just said, are there multi-turn actuators? I don't know if that means they can turn more than 360 degrees or what that means. I'm guessing the answer is yes. Belimo probably makes it.
Yes.
But and then next question, what's the life expectancy of Belimo actuators?
Well, we do test for life expectancy in our actuators. Some have gone 20 years, 25 years, even longer in the field, in field applications that they've lasted. We do have a 5-year warranty, and I think, Tom, you can attest to how well our actuators work, and you probably wish they had failed a little bit sooner so you could sell more of them.
Yeah, we switched to Belimo many years ago, and they just have been outstanding. They just work, and rarely is it actually an actuator problem. Working with the dampers on our residential side, my brother Joe that heads up our heavy commercial side, they use Belimo valves and actuators exclusively, and I don't think I've ever heard my brother Joe mention an issue with either one. So I think you're buying the very best if you use Belimo. And then I received one more question. We'll just go ahead and knock it out. Does Belimo make a receiver to activate an actuator by a Wi-Fi signal? For instance, a leak detector calls a valve to be closed.
That we don't have currently. That's something that could be somewhere down the pipeline, but at this point, it's not something that sounds like it's more of a controls situation, and we're not a controls manufacturer, as you know. We are a valve and actuator manufacturer.
But you do have a platform where you can actually custom design actuators. So if you had a OEM that wanted to do something special with a special algorithm, you actually have a platform that can be loaded right onto the actuator itself, I believe.
That's correct. Okay. That's correct, yeah. Yep.
Let's see here. Next, one more question while we're stopped. Do you allow HVAC technicians to repair Belimo valves? I'm not sure if he's asking a replace versus repair or what exactly there, but
yeah, I guess the only thing I can think of repairing a valve would be like maybe a glow valve in their repacking kit. That's a possibility. I mean, that's something we do offer. But really, if a valve fails, it fails and it needs to be replaced. It's really not a whole lot of repairs that are available that you're able to do to them. So, I would say in the rare instance of the valve, like I said, maybe a glow valve is the only instance I can really see where there would be a need to repair the valve itself.
Yeah.
We're talking about repairing actuators. That's not something we recommend. If there's an issue with it, if it's under warranty, we'll replace it.
Yeah. You'll be much further along and safer just to replace the whole actuator if needed.
Yeah.
So, all right. Yeah. I think that's it for now. We'll let you get back to the presentation.
All right. Thanks, Tom. So we're going to now move on to control valve sizing. And this is another situation that you'll see in the field. You're maybe not sure what valve to go to, what CV means. That's all over the place, CV, GPM. So we're going to get to the basics of how to size a valve properly. So the goals of this section is to understand what information is needed for applications in order to select the proper Belimo control valve and demonstrate best practices for sizing and selecting pressure-dependent control valves. And this part of the presentation is going to focus on pressure-dependent valves just because you have CV and pressure drop and these things that are involved in it. Whereas pressure-independent valves, all you need to know is the GPM, so it makes sizing valves a lot simpler. How are we going to select a control valve? Well, there's two typical scenarios, right? Well, for when you need a control valve, it's in a new construction or replacement retrofit. So these are the valve selection parameters that we're looking for. And a lot of times, we're not going to have all this criteria. We're going to have some of it. And we don't need everything here really in order to size the valve, but it's helpful. We're going to go through each of these from media to pressure rating and close off in this section. So in commercial heating and cooling applications, our media types are going to be chilled or hot water, glycol, and steam. So that's what we talked about our media. Now we're going to look at CV. So what is CV? The abbreviation for coefficient of flow. So basically, it's the amount of water flow in GPM through a fully open valve with a 1 psi pressure drop. If you have a CV that's too high, that means you're going to have an oversized valve. It's going to result in sloppy and energy inefficient performance. On the opposing side, if you get a CV that's too low, it could result in inefficient flow and you could starve the coil. How do you calculate CV? So you do that by taking the GPM divided by the square root of the delta P. Now, delta P can be measured by taking the difference between water pressure measurements on each side of the valve. That's how we figure out the delta P. So the valve requirement questions we'd like to ask and like to have, the information we'd like to have when we're going to size a valve is what's the GPM, what's the delta P, and what's the CV. Most cases, we're going to know the GPM. Are we going to know the delta P? That's a possibility depending on the schedule that you get or what you're looking at, or if it's just a single valve replacement, you may not know that. And what's the CV? If you're lucky and you get a specification or you get a schedule or somebody calls you and says, hey, I need a valve that's going to do 10 CV, you're ahead of the game. So in this particular example, what data do we have? We have the GPM and nothing else. So what do we do in that situation? So the rule of thumb for delta P is between 3 and 5 PSI, and that comes from an ASHRAE standard. What we like to use at Belimo is 4 PSI for a couple of reasons. One is it falls right between the 3 and the 5 of the ASHRAE standard. And for the second reason, it's very easy to figure out the square root of 4. So we're looking at this valve. What's CV for a coil that requires 40 GPM with a delta P of 4 pounds per square inch? So on our CV calculation, we see it's GPM, which is 40, over the square root of the delta P. At this point, we don't know what the delta P is, so we're going to plug in the 4 that we talked about. So we're going to go take 40 divided by the square root of 4, which is 2. And that's going to give us our CV of 20. Hopefully that makes sense. I kind of went through that sort of fast, but it's pretty simple if you're using the delta P of 4 to make these calculations, because basically you're halving your GPM. So the exercise here that we'll walk through to figure out the GPM, the CV. So as you're sitting and looking at our screen here, you can see what's the GPM with GPM of 17 and delta P of 4. What's our CV going to be? That's basically half of 17, which is 8.5. You do 17 divided by the square root of 4. That's how you get to that 8.5. This one we just did, so you should know the answer to that one. This is CV of 20. Now, this third one is the easiest one out of the 3. It's 825 GPM. We have a delta P of 3. Any of the very fast math people and math geniuses in the crowd probably already know the answer to this, but it's 476. So you take the 825 divided by the square root of 3, and that's how you get to the 476 for your CV. So when you're sizing pressure-independent valves, as I kind of mentioned before, it's a lot easier. So the rules we just talked about with the CV and the 4 PSI pressure drop only matter when it comes to pressure-independent valves. We're talking about pressure-dependent valves. We're talking pressure-independent. We don't need any of that information. We just need the GPM. That's how we're going to size. Something else to take into consideration and kind of have in the back of your mind is pipe reduction factor. So piping geometry should be considered when using pipe reducers. So that means if you're going from a 1-inch line down to a 3/4 inch valve, there can be some changes to the CVs that you're going to get when you reduce the pipe sizes. So in this example here, we're looking at a B230 1.25 inch valve. Our CV rating is 19. So if we're going to go, say, from a 2-inch pipe down to our 1.25, we're going to use a 1.25 inch valve on a 2-inch pipe, it's going to change the CV slightly. It's going to drop it down to 18.2 instead of 19. Now on smaller valves, the pipe reduction factor is kind of minimal when you take it in the big scheme of things. When you get into larger valves, it's where you're really going to have to pay attention to pipe reduction factors. If you look at the bottom of the page here, we have like a B280 3-inch valve, which has a CV rating of 170. So if you're going down from a 5-inch to a 3-inch valve, you're going to be losing about 30 GPM, 32 CV. And in that instance, you'd maybe need to select a different valve. So we're also the next thing up on what you need to size valve is the ANSI leakage class rating. Belimo as a whole, the majority of our products on the valve side are going to fall in either to class 4 or class 6. So class 4 is a 0.01% leakage, and class 6 is considered bubble type. So that means negligible linkage or leakage. We do have a couple that may fall in the class 2 and class 3, but that would be globe valves on the flange side. But for for the most part, our offerings are going to be either Class 4 or Class 6. So we're also going to talk here quick about what ANSI ratings are. We have ANSI 125 and 150 on the flange side. We have ANSI 250 and 300. And when you can use these, it's mainly when you're looking at high-rise buildings in high-pressure areas. And here's kind of a look at the ANSI ratings for the various temperatures and what the various classes mean. And I see, Tom, looks like we have a couple of questions.
They ask, can you use the actuator in an open return plenum?
Yes, you can. I'd have to double check the on the specifications, but from past experience, I believe you can use them on an open air plenum or return plenum.
I don't think there's any issues there. And then got another question coming in from, let's see, do you have to select a valve with a CV not, if you have to select a valve with a CV not available, will you take the higher CV or the lower CV?
That actually they're jumping ahead of us a little bit. I'll get into that probably in a few minutes here. So if they can hold on for a couple seconds, we'll get a couple minutes, we'll get to there. So we're going to next move on to the last couple pieces on data that we'd like to have to size a valve. And that's the next one's close-off pressure. And basically that's the maximum differential pressure that a valve can withstand without passing more than its rated leakage. So rated leakage being that 0.01% or being bubble tight. That's what close-off pressure is. So here we go. We're going to get into this control valve sizing exercise, which one of our somebody just asked about how we size and what to do when it comes to CVs. So this exercise, we're looking at an application, an air handling unit. Hot water is the media. The design flow rate's 40 GPM. It's a popular number in our examples here is 40 GPM. Pressure drop is unknown, so we're going to use that 4 PSI. Pipe size 1¼ inches. We don't know if there's any pipe reduction factors we need to be concerned about. No ANSI considerations. Our close-off pressure is 100 PSI. It's a two-way valve, 24 VAC on the power supply. We need it to be 2 to 10. Our considerations are limited space, and they want it to be pressure dependent. So basically, we have 4 options from the Belimo valve catalog that will fit this. We have our CCV, we have a standard ball valve, we have a V-ball, and we have the globe valve. So in this instance, any one of them could work, but the CCV is the best option for the reasons because it's at lower cost. It has a high pressure close-off, so the close-off pressure, so that'll work. The valve is maintenance-free for hot and chilled water, and it's got a lower profile. And that's really what the key characteristically we're talking about from that example. Now, we could use a ball valve, but it's going to be higher in cost. We do have a limited sizes from 1/2 inch to 2 inch. It does have the high close-off and temperature ratings we're looking for, but just I think the big thing here is cost and the space required for it. The V-ball, it really is a specialty valve for more steam and high temperature hot water situations, so really not the best option for this example. Then the globe valve is an option as well, but again, it's at a higher cost and has a larger profile, and at some point a globe valve might require maintenance. So now let's look at the CV calculation for this particular example. So the valve must pass 40 gallons of water per minute so this is a formula we know, right? Figuring out the CV. So we know our CV for this particular valve, or for this particular instance, is 20. How do we select a valve to make sure that it's not oversized or undersized? So if you see here on the left-hand side, you see 4 different options that would work in this application. So you see you have the B221 has a CV of 24. We have the B224, which has a CV of 19. We have the B230, which also has a CV of 19. And the B231 has a CV of 25. So any of these could potentially work. But let's look at the delta P formula here. So this is used to calculate what pressure will be needed to have the required flow when using the selected valve. And this one we're going to use to figure the 19 CV valve. So we're going to calculate this by doing this delta P formula. So in order to figure out the delta P, we're going to take the GPM divided by the CV times 2. So in this situation, we know our CV is 19, we know our flow and GPM is 40, and that leads us to 2.1 times 2, which means our PSI pressure drop is 4.4. That's great. It falls within the ASHRAE guidelines we talked about with the 3 to 5 PSI. So we could use this valve. Now let's take a look at the valve that has a CV of 24. Using our calculation here with the GPM divided by the CV squared. So 40 divided by 24 gives us 1.6 times 2 equals 2.56 PSI. So that does not fall within our guidelines here. So we really cannot use this valve. If we do, it's still slightly oversized, which means our control is not going to be quite what we're looking for. So if you look at our two options with the 19 CV, and this is from our PGPL, which is our product guide and price list, we have two options here. We have a 1-inch valve that will give us the CV of 19 that we're looking for. And we also have a valve that's a 1 1/4 inch that's going to give us a 19 CV also. So either one of these would work. Now, earlier we talked about pipe reduction factor. We don't know if there's any instance like that, if that's going to be a factor. But if we do install this 1-inch valve into a 1 1/4 inch line, there's going to be a slight difference in the CV. That's what's going to knock it down just a little bit. So if it were me, if I had to choose between the two valves here, I would probably pick the 1 1/4 inch model, just because you're taking pipe reduction factor out of it. The only way I would think about maybe going with the 1-inch valve is cost is an issue. Now, if I remember correctly, we're talking about a $20 difference at list price on these. So I think for better control and tighter control over this valve, I think a customer would be willing to pay a little bit extra for it. So we just ran through some of the valve sizing here. Do we have any questions that have come up since then, Tom?
We do not have any questions currently.
Okay. So we're going to move on to our last section here, which is an introduction to retrofits. So what we're going to cover in this section is the steps for selecting the correct retrofit linkage, locating the valve model number in the field, looking up the valve make and model number in the retrofit guide and price book, selecting the appropriate actuator for the chosen UGVL series or UGLK kit based upon application requirements. And then we're going to do just a quick talk about custom retrofit kits as an option. So what do you do with old valves and old actuators? They're operating improperly, sloppily in a lot of cases, or they just stop working altogether. So what this leads to is performance is bad and energy is being wasted. So why is retrofitting preferred over replacement? Well, the assumption is usually that it's the valve that's causing the issue and that the valve is failing, but it's really not the case. It's usually the actuator that's going to fail before the valve does. So the solution, you'd think maybe, is to replace the actuator with an identical model. That's maybe not always the case, especially if you have an old pneumatic system and you want to replace it and move to a modern TGC system. You can't replace the pneumatic with a pneumatic. And sometimes the replacement actuator that's on the market now may not be compatible. And the other case is the existing model of actuator, kind of like I said before, is obsolete. So what is our option? You replace the old actuator with a new state-of-the-art one, and you can improve the HVAC system's operation and efficiency. So the most common replacements that we have that our universal kits will fit on will be ones by Stockham, the NIPCO, the WD2000, LD2000 series, the Johnson Controls VG7000 series. We have the flow rights, the 599 flow rights that we're probably all familiar with. And then that's the CB, the V7 and VB9, the Honeywell V5011, and then the Bray on the butterfly side as well. So what are the steps in retrofitting a globe valve? So we need to determine the make and model number of the valve. What I get a lot of when I have customers say they need to retrofit an actuator is they'll send me a picture of the actuator information. And that's not information that we need. What we need is information on the valve, because it's going to be the linkage is going to need to connect into the valve assembly, the valve stem, in the bonnet. And those are all things we're going to need in order to select the proper retrofit linkage kit. We look up the valve in our retrofit solutions technical documentation, or on our price list, or on our Belimo retrofit app. We're going to select the linkage kit by the valve model number. We'll select the actuator based on that chosen linkage kit. We're going to mount the linkage to the valve, and boom, there's your retrofit. So the first thing we're going to do is try to find the manufacturer's name on the valve body. So it can be in any one of a number of places. You can see on the CV valve, it's actually embossed onto the valve body itself. In this particular one over here, it's a Johnson valve, so it's a small tag that's connected to the valve body itself. Or you might even see something like this, where it's a brass or metal strap that's actually strapped around the actuator. It's going to go back here quick to the valve body and information. If you run into a situation where you have a valve and you're not sure if it's going to be a regular, a universal kit's going to work on it, I would say send as many pictures as you can of the valve assembly. Like take pictures anywhere you see model numbers. Anything that looks like model numbers, take a picture of it. If I try to find a tag, sometimes it's buried beneath insulation. Then maybe that's hard to do. But if you have any questions or not sure if a universal kit's going to work, I would highly recommend sending it to one of our tech support team, and they can help you out, let you know if it's something we will have a universal option for, if we need to go custom, or you can send it to me as well. Okay, so the next thing we're going to do is go to our retrofit solutions guide, which I believe that's attached as one of the resources here that you can download and you can use after this presentation is done. So this is what a page looks like in our price list in our retrofit documentation. So here you see we found a Siemens Landis & Power. So we have it broken down. Each page is broken down by the manufacturer. Then it goes from valve size, from the smallest, like say 1/2 inch, up to the biggest, which may be a 6 inch on the globe valve size, and maybe up to 12 inches on the butterfly valve side. So we're going to review our linkage options. So for this example that we're going to walk through here, we're going to use a Siemens 658 series 3-way globe valve. That's what we're looking to retrofit. And let's see walk through the steps, what we're going to need. So found out, we got it. This is the 658 series. It's a 3-way. We see the 1 1/4 inches. Next question is, do I need fail safe or not? In this particular valve, we have the option of yes or no. And in this example, we're going to say we don't need fail safe. What's the close-off requirements? In this example, say the close-off is 200 psi. So we have 2 valve options here that cover 200, that would work with the 200, have more than enough to handle up the 200 psi. Now you can see we have 2 options. We have the UGVL and the UGLK. So why would we choose one of those over the other? Just for visual, if you haven't seen one of our retrofit kits, on the left is the UGVL, on the right is the UGLK. I'm going to be talking about a lot. There's going to be a lot of U's and G's and L's in these next few slides, so please bear with me. They can kind of get jumbled in your brain, but hopefully we can keep them separated. Tom, I see you have a question.
Yep. We actually had 3 come in here all at once, so appreciate that. The first question, what adapter should I use to actuate an 1.5 inch angle steam radiator valve? What actuator torque would you advise?
See, it's really going to depend on what's on there currently. It's really something that we'd have to take a look at, see pictures of, to figure out what kind of actuator we're going to need on it without knowing more than just the valve size. So that's something, like I said, we can get that information, send it to our tech support team, and they probably could come up with a solution.
Yeah. And how do they get a hold of your tech support team? Is there an email or a tech support phone number?
There is. We do have our tech support and customer service is available, and we'll get into that a little bit closer to the end of the presentation, and I can talk a little bit about what they can offer us. So if that's okay, Tom, we'll wait until then.
Yep, absolutely. Okay. Next question. How do you set the closing stop torque on the actuator?
So on a retrofit?
I'm guessing since that was the section we were in.
Okay, that's going to be done can be done on the UGLK version, and that's I don't have pictures or anything to really show what you can do on the top of the actuator to set it, but that's something that can be done with on the UGVL version of this retrofit.
Okay. And then the last question from Joseph at Grave Sheet Metal. In reference to fire smoke dampers, if I am replacing an obsolete actuator without any data to refer to, do I take the static or dynamic performance in account with the size of the damper, or is it only by the damper size?
The biggest thing it's going to be damper size. So if he was able to get us what the size of the damper is, we could be able to select the proper fire and smoke damper port.
Yeah, so damper size is the critical thing.
Yep.
All right. Excellent. That's our questions for now.
Okay. Well, thanks to everybody for bearing with some of the technical issues here. We're getting close to the end, so just hang on. Okay, so we talked in the previous slide about, in this example that we were going through, we have a UGVL kit that's an option, and so is the UGLK. As you can see, they're different assemblies, a little bit different look, and they have different features and benefits. So we're going to kind of go through a scenario of why one would work better than the other. So here, the first scenario is, let's just say you have some extra AF actuators, like damper actuators from a previous job. You don't want to return them and maybe take a hit on the restocking fee. And you know the AF's going to work on this particular application. You can use an AF actuator on a UGLK retrofit kit, as you can see on the picture on the right. That save you money, and you'll be able to use these actuators that you think have to be returned or sit around until another use came up. So in that situation, you could use the UGLK, save yourself a little money. But it would not work with the UGVL because there are two specific actuators that work in our UGVL retrofit kits, the LV and the SV. So that's not an option. What about the stroke requirements? Is it greater than 3/4 of an inch? So say you require multiple linkages on this particular job. So say you have some Honeywell actuators, you have some Siemens actuators in this particular installation. What do you do? Which is the best option? So with the UGLK, we have different model numbers that will work for the different manufacturers. So UGLK will work for one manufacturer, 1800 will work for one, the UGLK 1200 will work for another one. We have an UGLK 1130 that would work for somebody else. So in that scenario, you're requiring multiple linkage kits to cover these different manufacturers. So that's probably not the best option. A better option would be the UGVL, which means it's universal, and it can adjust to many of our competitors' valves with just that one linkage. One other scenario here is say you run into this kind of odd control signal. Maybe it's an old actuator that's installed at a 0 to 135 ohms, the control signal that's required. The UGVL does not have that option. The UGLK, we could find an actuator that could run on that control signal. Now, this one is probably one you're going to run into more than you would, like maybe one of the examples about having the extra actuators or the 0 to 135 ohm situation. What fail-safe option is specified or preferred by your customer? So we have electronic fail-safe and spring return. Sorry, I skipped ahead too quick here, but the VLs, so UGVL and SGVLs, are only available in electronic fail-safe. The UGLKs have the option of either doing electronic fail-safe or spring return. So as you can see, The last example here, we're going to look at runtimes. So you want something that's going to have a faster runtime than our standard 150 seconds. The UGVL offers 35, 60, and 90-second runtime speeds, whereas if you're putting one of our damper actuators on the UGLK, we're looking at getting a C-type actuator. We have limited sizes that we can get in the C-type, and it's going to be probably a little bit more costly than it would to just go with the UGVL. Now, those are available. We can do almost anything with these. So butterfly valves, globe valves, it's pretty amazing the things we can do. What I would say with this is you could technically go out and measure up a valve assembly and send it in and do it on your own, but it's a custom product, and that means it's not returnable. The best way to probably go about this and have somebody who does it all the time take the measurements is have myself or another DSM across the country or district sales manager come out and take the measurements for you. In that situation, if there's something wrong, if measurement's wrong or the retrofit kit's not working 100% correctly, then it falls on me. It doesn't fall on you guys or the person or the company that you're buying the Belimo from. So we do custom retrofits. Like I said, you can do all kinds of crazy things. But if you need something like that, reach out to your local district sales manager with Belimo, and they can help you through it. So like I mentioned here quick, we have stock offerings that are available in 2 to 3 days on the retrofits. The custom is available in 4 to 6 days, which is pretty crazy that somebody can make a custom linkage kit for you in less than a week. So we have quickly, and some of this stuff is in the resources guide that's a part of the presentation. But Retrofit, we have a Retrofit app that you can find on the Apple App Store or Google Play. I use it all the time when I'm in the field. We have that Retrofit documentation booklet, which is you guys can download here at the end of this presentation. Those all are great tools for retrofitting. So our customer support team, somebody asked the question about that earlier. So we do have tech support and customer service. Our tech support team has won awards from Controls Trends and other societies. They're really good at what they do. And we have the tech support team. So the number you see here listed, the 800-543-9038. That's one to memorize. That's for customer service or technical support. So we have our office in Danbury, which is in the Eastern time zone. They start at 8:30. They go until 5. We also have an office in Sparks, Nevada. So they're in Pacific time. What that means is if you're on the East Coast, you're working on a job past 5 o'clock, you're going to be able to catch somebody in Nevada until 9 o'clock Eastern time. I'm in the Midwest in the central time zone in Chicago. That means I got 2 extra hours to get somebody if I'm at a job site after 5 p.m. And if you're in the central time zone also with the Eastern time zone, that means I call somebody at 7:30 and get them. So that's a great option, something to think about. And it's very seamless. What happens if somebody calls at past 5 p.m. Eastern, it's going to automatically roll to our call center or our customer service and tech support team in Sparks. I will also say I've had a great story that happened to me is I had a customer that needed something next day. It was at a food processing facility. We had it in stock. I got it to our Danbury facility too late. I called Sparks. They were able to ship it out before the day ended, and it got to my customer the next day. So you get into one of those tough spots. If you're on the East Coast and need something next day or quicker, then you might be able to get it from our Danbury office. There's somebody in Nevada that can help you along with those things as well. And if you're joining us from Canada or Latin America or Brazil, you can see contact numbers there as well. A couple other things that's just to go over that if you're not familiar with it yet, we have a YouTube channel, which is great. You can find anything on there from quick sort of short tips from our tech support team. They may get a ton of questions about a particular thing or like a particular item or a particular product. And they'll put a quick 5-minute video together where they'll show how to fix that particular problem, kind of like a frequently asked questions video. They also have recorded webinars where you can see anything from energy valve presentations to the retrofits to damper actuator sizing and troubleshooting. It's got a ton of stuff, so I would highly recommend if you get a chance, subscribe and go to our YouTube channel. We have a selection and sizing tool called Select Pro that you can download a version from our website, or there's a web-based version of it. It's great for if you have a large number of products that you need to select. Enter all of the data that you need, like GPM, CV, pressure drop, and all those things will allow you to select the proper valve for whatever application or job that you're working on. And finally, we have Belimo University, another great training site. They have recorded webinars. They do live webinars. They have PDH courses if you're an engineer. They'll tell you about any classroom trainings that are going on at our headquarters in Connecticut, which probably won't be happening for a while. But all you need to do is enter your email address and a password, and it'll sign you up, and you'll get notifications when new classes are coming up and new topics are coming up as well. And with that, we'll wrap things up. If there are any other questions, I quickly just want to say thank everybody for your patience with our technical difficulties here, and hopefully it was a beneficial presentation for everyone.
Yeah, thanks, Ken. We really appreciate it here at Jackson Systems. A lot of great technical information. Again, make sure you download those resources that are at the bottom of your screen. And of course, you can always use those links to watch it later on or share with fellow team members. And on behalf of everybody here at Jackson Systems, we want to thank Belimo and particularly Ken for joining us this evening. And with that, have a great night and be safe. Thank you.